So the last U sub that we did in this section was trig substitutions. So we had this type where we substitute a sine or a cosine to work through that problem. And we had this type where we substitute a sine, cosine, sine, secant, or tangent to create something that we can use with our Pythagorean identities. So we're going to try both of those again just as a review, but together, just so you can see how they work. So the first one we're given as sine and cosine. So we go to our table and we look it up to see what we use. So sine is odd, cosine is even. So looking at it, sine power is odd. That means we're going to be writing u equals cosine theta because we're going to have an odd sign. So by making it a cosine, our du is going to be sine, which takes out one of the odds that we're looking for, leaving us with all even signs that we can then convert into the cosines. So we're going to say u is equal to cosine because the sign is odd. So that means we're going to take and rip one of the signs away from the sign, like this, so that is what our goal is for our du. So in order for that to work, that means our u is cosine t, so that our du would be negative sine t dt. So negative du is equal to sine t dt. This allows us to take this and replace it with du. So we now have sine 4t. Well, sine 4t is not in terms of cosine, so we need to rewrite that as well. That's 1 minus cosine squared t, but we have two of them because 2 times 2 is 4. Cosine 4t, cosine to the power of 4t, and then sine t dt. Now we can take and replace everything to make sure it's full u substitution. 1 minus u squared squared, u to the fourth, and then that is now du. So they're all gone. So now we just have to do a little distributing, right? And what I did forget is the negative, so let's throw that negative on there. Almost forgot that. All right, so now we end up with 1, if we square it, minus 2u squared plus u to the fourth du. Distributing this, we would now have, let's start with the u to the fourth. So u4 would be u to the 8 with a negative. And then u4, u2 would be u to the 6 with a positive. Because negative times a negative. So we're distributing the negative and the u together. So that would be u to the fourth negative. All right, now everything is in a nice, clean general power. And so we end up with negative 1/9 u to the 9th plus 2/7 u to the 7th minus 1/5 u to the 5th plus c. And then same thing as before, we just have to replace it with cosine t now. So negative 1/9 cosine of the power of 9t plus 2/7 cosine to the power of 7t minus 1/5 cosine to the power of 5t plus c. And there we go. So again, the whole point is to look for odds, for evens. Odds sine means we'll rip a sign out, so we use cosine because we'll get sine. That'll replace. If it was an odd cosine, we would use sine, which would give us a cosine, and we could replace it. All right. The other type that we did now is just using our basic 3. So we had a squared minus x squared and a squared plus x squared and x squared minus a squared for our trig substitutions. So on this one, we have a 1 minus x squared. So let's go back and look at our table and see what we need to use. So 1 minus x squared, remember that. So 1 minus x squared, that means we're going to choose x equals a sine theta so that we can get 1 minus sine squared theta and convert it to a cosine. So we are using sine theta. So our a here is 1. So that means we're going to say x is equal to just plain old sine theta. And you could use cosine too, but we use sine because we end up with a nice positive d theta like that. All right, now we just also need to plug everything in. So we're going to get 1 minus sine squared theta. That's what we wanted, so that we can make that into cosine. That would become sine squared. That becomes cosine theta d theta. So everything replaces. So we end up with sine squared theta. 1 minus sine squared theta. And then dx is cosine theta d theta. Now we just have to change our numbers. We got to go 0 and rad 2 over 2. So x equals 0 means that this would be 0 equals sine theta. And so this is between negative pi over 2 and pi over 2. So theta is equal to 0. If x is rad 2 over 2, same thing. Our theta here would be pi over 4 because it's again between negative pi over 2, theta, and pi over 2. So we're going from 0 to pi over 4. All right, now we just have to do our simplifying. So the whole point of this was to change this into a cosine, all right? So 0 to pi over 4, sine squared theta, cosine theta, d theta, all over cosine squared theta. So that one will cancel, and we end up again with 0 pi over 4. Sine theta over cosine theta, d theta with the square. All right. So now you may think, okay, well, let's try and switch it. So you can use any of your ideas to simplify. One of them would be to go, okay, sine theta over cosine theta, tangent theta. Sorry, I'm writing what I'm supposed to say. Sine theta. And so that would be tangent theta, sine theta, and you could keep going from there, but that doesn't give me anything I want. What I do notice, though, is sine squared theta is just 1 minus cosine squared theta over cosine theta, and I can use my division simplifying to work on this. And that's why I was saying that there are more techniques, not just steps. So we did simplify. There was nothing to simplify first, but then we used u substitution. But now what are we doing? We're right back to simplifying. So this is 1 over cosine theta minus, and then that would be cosine squared over cosine theta. So that would just give us cosine theta d theta from 0 to pi over 4. And so this becomes secant theta minus cosine theta d theta, and you can start to get excited because you know that you can find these. So this is secant theta, right? So that you get secant, sorry, you don't get secant. You get the natural log of secant theta plus tangent theta, and then the integral of negative cosine would just be minus sine theta as well. So now we go from pi over 4 to 0. So we're going to plug those in. The first one would be a natural log secant pi over 4 plus tangent pi over 4. And those are both in the first quadrant, so we can change this to parentheses. All right, and then minus sine pi over 4. And then the next one now is minus, so it's going to be minus plus, and we plug in 0. So ln secant of 0 plus tangent 0 plus sine 0. All right. So secant of pi over 4 is rad 2. Tangent pi over 4 is 1. So we end up with ln of rad 2 plus 1. And then this is also rad 2 over 2. And then down here we end up with secant 0, which is 1. And then tangent 0. So that's 1, like that. And that's 0. And that means the entire bottom part just becomes 0. So putting these together, we end up with ln rad 2 plus 1 minus rad 2 over 2. And you can check that in your calculator to verify that it is correct. But that was our trig substitutions that we did. And so these are other ones that you want to try. And then we're pretty much done with u substitution. There's other things that you can use for u sub, but I've covered a lot of different tricks in the last 3 videos, so try them all.